Good morning students. I am Dr. Betsy Claribel, Assistant Professor, Department of Chemistry. So here in this video we are going to learn about the refining of metals which comes under Unit 3 Metals and Metallurgy. So after the extraction of metals, the next step or the next process is the refining of metals. So refining process in the extraction of metals is a very important step in ensuring that the metal obtained is pure and free from unwanted impurities. So in order to get the pure form of the metal, we are going to conduct this refining process. So after the extraction of metal, it should be refined. So various methods are employed to refine metals depending on the metal type and the impurities present in it. So there are various processes used in the refining of metals such as electrolytic refining, distillation, zone refining, froth flotation and chemical refining. So these are the refining processes that are carried out after the extraction of metals. So each metal may require a specific refining process based on its chemical properties and the nature of the impurities present. So these refining techniques, they help to obtain the metals of high purity which are essential for various industrial application. So whenever a metal is used in industrial application, they should be very well refined. So the first process is the electrolytic refining. So electrolytic refining is a process of refining a metal, mainly copper, by the process of electrolysis. So during electrolysis, large amount of impurities, that is the impure metals, is used as the electrode, that is the anode, and a thin strip of pure metal is taken as the cathode. See, in this picture you can see that the impure copper is taken as the anode and the pure copper is taken at the cathode. So in this setup, an electrolyte, that is the solution, it contains the metal salt aqueous solution depending on the metal which is used. So the clean or pure metal is formed at the cathode when the electrical current of sufficient voltage is applied. So in this process, the current is applied, sufficient voltage is given so that the pure particles will settle at the cathode, and when it is applied, then the impurities are dissolved. So by dissolving the impure metal at the anode, so at the anode the impurities will go and settle down. At the cathode we will get the pure metal. So electrolytic refining is also sometimes referred to as electro refining. Then distillation. So this is a method for purifying metals with low boiling point such as mercury and zinc. So here the impure metal is heated above its boiling point to create vapors. So in the process of distillation, the metal is heated to reach its boiling point and the vapors are created, and since the impurities do not evaporate, they can be easily separated. So this is one of the method for refining the metals. Then zone refining. So this is a highly effective technique for purifying the metals like silicon, germanium and other semiconductor materials. So it involves the moving of a molten zone along the solid metal. So we are going to take a metal and a molten zone will move along the solid metal where the impurities are concentrated in the molten part, and after that they are removed. So in that zone the impurities will get collected. So in this process a metal bar is passed through a heater that melts a small part of it. Then the molten zone is then moved along the length of the metal and it carries the impurities along with it. Then the purified metal will solidify behind the molten zone. Then example, zone refining is widely used for the production of high purity silicon used in electronics. Then chemical refining. So it is an example of chemical refining is the nickel carbonyl process, in which the impure nickel metal is selectively reacted with carbon monoxide gas to form nickel carbonyl gas. So this gas is then decomposed to give the high purity nickel metal. So chemical refining involves either the condensation of metal from a vapor or the selective precipitation of metal from an aqueous solution. Then the next process is the Van Arkel de Boyer process. So it is a method for purifying metals, particularly used for refining titanium and zirconium. So this process is based on the principle of converting the metal into a volatile compound and then decomposing that compound to obtain the pure metal. So it was developed by Van Arkel and Jan de Boyer in 1925. So the steps involved in this process are the formation of metal halide, then decomposition of metal halide, and then collection of pure metal. The formation of metal halide is the first step. So here the metal is first converted into the metal halide by the reaction with halogen. Then this is done at very high temperature so that titanium reacts with iodine to form titanium tetraiodide. Then in the next step, for zirconium, the zirconium reacts with iodine to form zirconium tetraiodide. So a metal halide is formed in the first step. Then the next step is the decomposition of the metal halide. So now the metal halide is then heated to a high temperature in the presence of a filament of the same metal. This causes the metal halide to decompose, so leaving the pure metal behind, which then collected on the filament. So in this way we are able to get the pure form of the metal. Then collection of pure metal. The pure metal that is deposited on the filament can be then collected and further processed as needed. So applications of this Van Arkel de Boyer process is particularly valuable for refining titanium and zirconium, which are difficult to purify using other conventional methods. So this method is the more effective method. So other methods like electrolysis, due to their strong chemical reactivity and high melting point, is not that much used. So it is primarily used in the production of high purity titanium. So in order to get a high purity titanium, this Van Arkel de Boyer process is used, especially for aerospace, medical and other specialized industrial applications where the metal's strength, lightweight and corrosion resistance are required. Then the advantages and disadvantages. So the advantages are high purity metal can be obtained. Then the process is particularly used for metals with high reactivity and melting point such as titanium. The disadvantage is that it is relatively slow and very cost effective on large scale production. Then the process requires the use of halogens like iodine or chlorine, which are very expensive. So therefore, as a sum up, the Van Arkel de Boyer process is an important method for producing ultra pure titanium and zirconium, especially in applications that demand the highest quality and performance of these metals. So these are the various refining processes used to refine the metals. Hope you understand. Thank you.